Okie dokie. So now we're on to 13.2, which is going to look at analyzing data. So in 13.1, we looked at different ways to represent data, maybe organize data. Now we're going to look at more the analyzation, which we did start a little bit in 13.1 as well. So for this first part, day one, we're going to look at how do we interpret and use mean, median, and mode. So we've mentioned those before. We're going to talk about measures of central tendency. So think about things around the center. How does the data look? And best representation. What would be the best value to use to represent a data set? Because we have lots of numbers at our disposal. What makes the most sense to use? I want to talk about something called standard deviation. Standard deviation is used in a lot of different things and looking at distribution of data and where data values fall. So it's an important calculation to be able to make. So we're going to look at it both doing that by hand, but then also utilizing our graphing calculator to talk a little bit about how to find some of these things as well. So let's jump right in. Mean, median, mode are what are called measures of central tendency because it's something that tells you something about the center of the data, where the data is centered. So it's a single value that's most representative of the entire data set that you have. So mean, median, and mode are three different numbers that we can use to measure that central tendency. So we're trying to figure out what makes the most sense to use. All right, so I think you know what all these are. So I'm going to have you go ahead just for a moment and think about those first three, mean, median, and mode. How would you describe those? So go ahead and pause the video, think about what each of those mean, pun intended, and then we'll talk through the definitions. All right, so let's start with mean. Another name for that is average. That's taking the sum of all the data values that you have and dividing by how many numbers in your data set. So we're using the variable n to stand for the number of values in the data set, so divided by n. Median is the middle score. When your numbers are ordered least to greatest or greatest to least, make sure you have your numbers in order. So median is the middle number, the middle score, which sometimes can be the best representation. When you have two middle numbers, in other words, whenever you have an even number of values in your data set, or when n is even, you do have to average those middle two values. So you sum them and divide by 2 to calculate what the middle would be. So the median doesn't necessarily have to be a value that's actually in your data set if that's the situation you're looking at, if it's an even number of values. And then the last one is called mode. Mode most often, they both have an O in there. So mode is the most often or most frequent occurring data value. So sometimes you can have more than one mode. So you could have maybe 7 3s and also 7 5s, and that's the most occurring. So you would have two different modes, and so they would call that bimodal. It's totally possible to have more than that, but like you'd have 3 modes or 3 most often occurring. So that definitely can happen, but mode just means the most often occurring data set. So how do you choose? That's really the big thing, because we can calculate all these values. How do you choose? You're trying to find which central tendency number is most representative of your data set. So which measure is the closest to most of the data. And so we want to take a look at and see what would be the most representative of the numbers that we're dealing with. So we're going to take just a tiny data set so we can do the calculations quickly. Now we're going to talk about what do we think best fits the data set. So here's what I'm going to have you do. There's your data set. I want you to go ahead, pause the video, calculate the mean, the median, and the mode for this data set. And then we're going to talk about which would you use to be your measure of central tendency. Is there a choice that stands out to you that would be most effective? All right, so let's check in and see how we compare here for each of these. So we're going to do our mean, our median, and our mode. So for the mean, add up all the scores and divide by how many scores you have. So the total, if you summed up all these values, I ended up with 84. And then how many numbers are in the data set? Looks like there are 1, 2, 3, 4, 5, 6, 7, 8. So our n in this case is 8. So 84 divided by 8 looks like it's putting us at 10.5. Median. So to organize for median, we want to put these in order from smallest to biggest and find the middle. Since there are 8 scores, we're going to have an even number. So we're going to have to average the 2 middle scores. So I just organized my data into least to greatest, and I kind of crossed off in either end, and I figured, oh, okay, they're going to be between 8 and 9. The average between 8 and 9, that is going to be most definitely 8.5. Probably didn't have to do the calculation, but that's what it would be. Average those middle two. Mode, what's the most often occurring? Well, it looks like we have 2 7s and we have 2 12s, so it's actually a 7 and a 12. So this is one of these that we would call bimodal because there's more than one mode. Bi meaning 2, so it'd be bimodal. All right, so which do you think you would use? Which do you think is most representative of the middle of the data? So let's kind of take a look at and see what you think about that. So one thing that I look for is this idea of outliers. So if there's numbers that are significantly above or below, we'll talk specifically about what makes an outlier in part 2. There's a mathematical calculation, but it's kind of gut feel. A lot of the numbers seem to be kind of right around that, 7, 8, 9 kind of ballpark, maybe even 10, 11, 12. Then we have this 24, and then we have this 5. So there's sort of outliers that are happening in there. So you might argue that an average is more swayed by outliers. It makes that value either be bigger or smaller depending on what's going on with that. So averages can be a little tricky with outliers in that data set. Then median would be a better option if you feel like you have outliers, because the middle score is going to be the middle score no matter how big the top number is or the bottom number. The modes in this case, 7 and 12, do you think that measures where the middle of the data is? Well, 7 seems kind of small. It's the second to smallest value in the data set. 12 seems kind of big because it's the second highest number. So I think mode would probably be off the table for sure. So if you think about the data set as a whole, you could decide maybe what you think is best. You might be leaning towards mean or median. If you're thinking, especially if that 24 seems awfully big compared to the rest of them, median might be your best option because it's not going to be affected by those outliers. So outliers is a conversation and a consideration that we have to think about when we're looking for our different values here. Let's take a look at another data set so we can have that conversation. So what I did is I put together a set of average incomes, average salary for a company with 25 employees. So our N is 25. We have 25 employees in this company. And this is the average. So you don't have to go through and calculate it. So the average is 83,872. So that's the average salary. So it's adding those all up, dividing by 25, that's the average. Here are the actual incomes of those 25 employees. So what are the mean, median, mode of the incomes? Well, the mean they already told you. So the mean, the average is that 83,000. The median and the mode, if we put them least to greatest to be able to tell, I'm going to go ahead and tell you what these are so we don't have to actually write it out ourselves. So you don't have to do that. The median, if I put them in order, I did that calculation for you. The median is 49,489. And then the mode, the most often occurring score, is 39,164. And then we already had the average up there, or the mean. So I'll go ahead and just write it so they're kind of all in order here. The mean is 83,827. Okay, so here's my question for you. Which do you think is the most representative of the middle, the measure of central tendency for this data set? Which measure would you use to describe this data set? I want you to pause, think about that for a second, look at all the values and see what you think, and then we'll have a quick conversation. All right, so which would you use? I'm hoping as you took a scan through the data set, you noticed some things, like the fact that we have some people making an awful lot of money here. So these 300,000 people, there's even another, I think there's a 168, that's pretty big as well. When you look at the average salary, then that is definitely, the mean is going to definitely be swayed by these outliers. So the idea that we have some outliers happening is going to make that average be higher than what it really should be to represent the middle of that data. So if you think about this, are the average salaries of people in the company, this is probably the CEO, maybe the VP, the chief operating officer, the chief financial officer, maybe these are the people, the executives, right, making an awful lot of money. We've got people that are making like 20,000 here as well. So it's, and a lot more people that are in the 30s and the 40s and things like that. It seems like this average is going to be out of whack, skewed higher because of those really three big, huge numbers. So I don't think mean would be a very accurate way to just set this, describe this data set. It would probably be much more accurate if we talk about the median, because the middle score is going to be the middle score no matter what. Doesn't matter how big the top number is or how small the bottom number is, the middle is still going to be the middle. Now, see how we can kind of influence how people think about a data set or a situation based on what numbers we use. If you were the CEO of a company and you were trying to attract people to come to your company and work and say, hey, we're such a strong company, this is a great place to work, which number would you use to represent salary? Well, you'd probably want to use the mean, wouldn't you? If you were the CEO trying to get people to come to your company, look at how great our average salary is. It's like $83,000. Most people that are working at the company aren't going to make that. So it's a really important thing to realize what numbers people are using and how that can impact how you think and interpret a situation. So people can definitely sway other people's feelings about situations by which numbers they use. So as a consumer, as a person in society, you need to always be analyzing what number are they giving me and what might that mean, pun intended. So think about that as you look at data sets. What's going to be affected by outliers? What might be a better representation? A great example of that is class size. So we talk about average class size, but again, if I were talking about class size, I would want to look at median class size, because there are some classes that are really big, really small, that are going to affect where most of the classes. That might be a better way to look at it. House prices, same thing. They often talk about the average cost of a house, but you get a couple of mansions in there and that's really going to skew that value. So median home price is probably a better thing to look at. So to be a good consumer of information, you really have to be aware of what's happening with the numbers and how people might use those to influence you in your decision making. All right, let's talk about variance and standard deviation now, so we can talk about another measure of data set. So looking at how dispersed a data set is. So we talked about central tendency, things around the middle, what's a good representation. Now we're going to look at dispersion, how dispersed or spread out data is, or how close together it is. So one measure of how spread out something is something called standard deviation. So how far or how much numbers differ from the mean, like how much above average or below average are you? We do this on standardized tests all the time. You talk about what percentile you're in, has to do with standard deviation. Are you above or below average? It's a way to show how people are distributed throughout the data set. So there's two different measures of dispersion that we're going to talk about that talk about how far something differs from the mean. One's called variance and the other one's called standard deviation. They're very closely related to one another. We calculate one to get to the other one, so they're pretty close. And another thing to think about then too with these numbers, what do they mean? The greater the standard deviation, the more the numbers in the data set vary or differ from the mean. So the bigger the number, the more spread out your data set is. The smaller the number is, the more compact or close together the data values are. So for me, that's really interesting to look at, like in test scores and things like that. The smaller the standard deviation, I know people are all doing about the same. Whether that's good or bad depends on what that number is. But if they're really closely together, I know, hey, everyone's kind of on the same page, we're pretty close together. If I have a really big standard deviation, it means people are really spread out. I have people all over the place, above, below, all spread out everywhere. So it's a really good measure of dispersion, how closely together things are measuring. So if you have a data set, so we're going to talk about how we calculate both of these. So they're going to use x1, x2, xn, those are your data values. So that's the data in your data set, whatever your numbers are. We have a symbol for mean. I probably should have said that back there. It's the X with the little line over it. So I'm going to go back to our first slide here. The mean or the average, the symbol that they use for that is this. They call it X bar. It's an X with a little bar over the top. That means mean, it means an average. So when we're calculating, we need to figure out the variance to standard deviation. We're looking at how far they differ from the mean. One of the most important things we need to calculate then is what is the average or the mean of the data set. So you're going to have a data set. You're going to have to calculate a mean. What we're going to look at then is the variance first. So the variance, we're going to use the letter V to stand for variance. And here is the formula for variance. And I'm going to go ahead and kind of put a cute little happy cloud around this so we can make sure you can find it. Let's take a look at what the calculation is. So x1 minus x bar. What you're figuring out there is the difference between the data value and the average. So how far the number is from the average. We do that with each one of the data values. Okay, so what you're calculating is how far above or below the average it is. Then we square it. Okay, we'll talk about why you square it. So if you have a number that's above average, so let's say we have an average test score of 70 and you scored an 80. That means you are 80 minus 70, you are 10 above average. So you're 10 away. But what if you score a 60? Well, 60 minus 70 is negative 10, but aren't you still 10 away from the average? We have to deal with that positive negative situation to be able to total up and average out how far we differ from the mean. So in order to take care of that positive and negative situation, we square each one of these differences because, again, I don't want to have them cancel each other out. I need the total amount that they differ. So it's the average amount that something differs from the mean. So I add up all of those differences and I divide by how many there are. So think about how you calculate an average, right? You add them all up, divide by how many there are. Then to get the standard deviation, so this is the important kind of follow-up to this. The standard deviation then, we use the variable sigma, this cute little kind of O with a little tag on it, is the square root of the variance. So you take that variance formula there, so your x1 minus x bar squared plus x2 minus x bar squared plus all the way down to your last value in your data set squared. You divide by how many numbers are there all together. That's your variance, right? When you take the square root, you're undoing the squaring. So remember how we squared to deal with the sign? We square root to get back to just what the actual true sigma or standard deviation is equal to. So we calculate the variance, how far it varies. We take the square root to counteract the fact that we squared it. So that takes care of the fact if we're above average and below average, they can still all count towards that total average away from the mean that we're trying to look at. So standard deviation and variance are how far on average do data values differ or vary from the mean. So we're just calculating that average to find out what that number is. So we're going to walk through a data set and kind of do this by hand and make sure that we're okay in doing that calculation. So we're going to look at the number of hours worked in a week. So we're not going to do a huge data set here, but this is a set of students. How many hours on average did you work per week? So we're going to try to figure out the variance and the standard deviation. So we're going to figure out both of these things for this data set. In order to figure out, though, how far something differs from a mean or from an average, that's the first thing we have to calculate then is the average. So the first thing I'm going to do is calculate the mean or the X bar. So can you go ahead and pause the video? Can you total up all of these scores and then divide by how many scores you have and calculate your mean, your average? All right, well, hopefully when you calculated them all up and added that all up, you were able to get our average, which I believe there was 110 total divided by 10. So the mean would be 11. So the average of this data set is 11 hours per week on average that people worked. All right, so how do we calculate? We'll start with the variance. So I'll do V first. We're going to take each of our data values and we're going to see how far they differ from the mean. So 20 minus 11. Then I'm going to square that. 15 minus 11. Then I'm going to square that. 9 minus 11. And then I'm going to square that. And on here. So we're going to do each one of these. I wrote way too big. All right, so I tried to write them all out so we could see them. So it's the difference between each data value and the average. And then we're going to square all of them and divide by 10. So we're just using the formula here. So what I want to show you next is what that looks like when we actually calculate those. So the score of 20 hours is actually 9, right, above average, so positive 9. The next one was 15. That's 4 above average. Next one, though, was only 9 hours. 9 minus 11 is negative 2. So that was 2 below average. But I'm going to square it so I'm not just canceling that out by having positives. It's still part of, on average, how far does it differ? So we need to account for all of that. 17, that would be 6 above. We have 18 minus 11, that would be 7 above. 7 hours is 4 below average. And then the 5 would be 6 below average. And then we have 2 is, 9 below average. And then our 3, that's 8 below average. And then 14 is 3 above average. So we're going to square all those, add them up, and divide by 10. So all of this is calculation you can be doing, obviously, on your calculator. All right, so I squared each of them, total them all up. So my variance is going to be 392 divided by 10. So that would be 39.2. Now my sigma, my standard deviation then, is the square root of that value, of that 392 divided by 10, or the square root of that 39.2, which is approximately, it's going to be a decimal value, 6.3. So on average, for this particular data set, the data values differ from the mean on average by about 6.3. So in that range, about 6.3 above the average of 11 and 6.3 below the average of 11. So between like 5 and 6 above would be about 17. So on average, that's 1 standard deviation above and below that average. So variance is just the square of the standard deviation. Another way to say that, the standard deviation is just a square root of the variance. So they're closely related. Now, I want to show you graphing, another way of doing this by hand, and then we're going to talk about it on the graphing calculator. There's a really cool alternate formula that sort of takes this all into account then right away. It's called the alternate formula for standard deviation. So it's still a calculation for sigma. So it's still a square root. And what you do, though, is you kind of average all of the scores first. So you take and all those squares of all the scores first. So you square each of your scores, you sum them, so all the way up to your last data value. You divide by how many scores you have, and then all at once you subtract off the average. So instead of having to calculate the difference each time, you just do the difference between the average at the end. So you take the sum of the squares of all the scores divided by how many you have, that's that calculating the average value of the scores, and then you subtract off the mean, the squared, and take the square root. So it's kind of a cool way to do that, and I want to show you what that would look like for this data set as well. We know what the answer is supposed to be, so we can double check. So this is the exact same data set, but let's go directly to sigma then by using that alternate form. So for this one, kind of nice, you don't have to calculate all those differences. We just take all of the scores and square them. All right, so I have squared all my scores, summed them up, divide by 10, and then subtract that average, the mean, 11 squared. So that's the alternate formula. Some people prefer this one because they just think it's, I don't know, a little bit easier to look at. So we can total up all of those scores. So go ahead and pause the video, total them up, divide by 10. So I think that was 1602, if I'm remembering correctly. Divided by 10 minus 11 squared. Totally didn't need that big long square root there. And then let's see what that would give us here. So we would have, looks like that would be 160.2 minus 121. And then take the square root, and you're going to get approximately, again, 6.3. It's just a different way of making that calculation. So some people really prefer that alternate form. Now let's talk really quick about how we do this on the graphing calculator. So it's going to be in the stat menu. So I'm going to go ahead and go to my stat menu, and we're going to go to edit, and I just want you to go ahead and put in your data list. And I'm going to show you a bunch of different things you can do here. So in your list one, we're just going to go ahead and type in those data values. If you happen to have numbers in your list already, the easiest way to get those out of there is go to your list one, put your cursor on the list one, press clear, and then enter. It'll get rid of all the values in your set. Never press delete. That gets rid of your entire list. You want list one to still be there. All right, so go ahead and pause the video, go ahead and type your data values in. When you get to the bottom of your list, it should say list one 11 equals. After you press enter after that last one, that means you have your 10 values in your list. You can be pretty confident you got all of them. The nice thing is too, it doesn't matter what order you put them in. So now we're going to go to do a calculation. So we're going to go to stat and then over to calculate. We want one variable stats because we only put in one set of information here. I'm going to go ahead to enter. Is your data in list one? Yes, although you could have lots of different lists of data, but ours is in list one, and I'm going to calculate. Now I want you to notice what you can see here. There's awesome things. Very top, x bar equals 11. There's your average. So nice little shortcut here. You could type your data values in, and will calculate an average for you, especially if you have a lot of numbers. It's a great way to do it. You don't want to have to add them all up by yourself. The next thing underneath it with our summation notation, hopefully you remember what that symbol means, or you've seen it before. That means the sum of all of the values. So that means the total of all of our x's was 110. Sure it was. Sum of the squares. Notice we just used that in the alternate form. The sum of the squares was, look at that number. Ooh, there it is, 1602. So it tells us that as well. So in that alternate form, it gives us the sum of all the squares, so we don't have to add it up. What I want to look for is 2 down from there, sigma of the x's. So sigma of the x's means the same thing as standard deviation. So there it is. There's our 6 point. Now we rounded to 6.3, but 6.26, that would round to 6.3. So it works out super great. So it will tell you your standard deviation. Also tells you n is 10. That's the number of values. And if you're going to do things like a box and whisker or something like that, or some of the other types of graphs that we've talked about, the x-min is 2. That's the smallest in the data set. Your first quartile is a 5. Median is 11.5. the third quartile 17, and your maximum score on your data set was 20. So you get all sorts of great information in your one variable stats on your calculator. So it's kind of a nice way to be able to double check and save yourself a little bit of time as long as you know what those numbers are. So standard deviation and variance, great way to measure how dispersed your data is, how spread out or close to the mean something is. And then the other part we talked about today was mean, median, mode, measures of central tendency.